we're going to go through a new app called ISS On Live. This is the International Space Station. You can view the Earth and space and all. Let's go find the icon. This is free. It downloads from the Play Store. There it is. Allow it to access device location. That way it'll know where you are and can show you where the satellite is. See there, that top one is view of the satellite, where it is. The bottom one is the actual view of the camera, but it seems to be rather dark right now, but settings and stuff. You can look to see when it's going to be around you again, because it checked your location, remember? So it shows you it's going to come right through there. Tells you the date and time. If you hit that little square down the bottom right corner, it'll change it to the side view of it. Full screen. Now hit it again, it goes back to the double view. Turn your phone over and it comes back to here. You can see the path it's on as it goes past different places. It's over Southeast Asia right now there. There's where it'll be over us again, different times and dates. See, it shows you, that red dot shows you where it's going to cross us. Its path. Different things you can do here. It's a pretty good little camera. It has a NASA television on it too occasionally, where they're talking to astronauts and all. Has its own recorder where it'll record video for you. I'm kind of anxious to get some views of the Earth here as we can. You can change stuff up if you want to. Comes up pretty much good little view as it loads there. Loading the camera right now. Space Station's cam. There we are. Kind of see the edge of the space station there, don't we? There you got a double view. If you hit that bottom right corner where it says 720, it goes to this. It's a full view of the phone. Hit it again, it comes back. We'll do a little bit more recording a little later and get something different here. Let's see what we got now.
From Victor Glover, the astronauts now preparing to doff their suits.
This is NASA TV.
Another look back at everything they accomplished today, completing all of their scheduled tasks and even several of their get-ahead tasks. First, the spacewalkers completed the battery upgrades that began in January 2017 by driving a final bolt into a lithium-ion battery and installing a final adapter plate to complete the power circuit. They also installed a bolt into a DCSU, or direct current switching unit, before Mike Hawkins moved to remove an H fixture. That prepares the International Space Station for future power upgrades. There were 3 cameras upgraded or replaced today. The first was a CP3 HD camera at the starboard truss. There was also a camera replaced on the Japanese experiment module remote manipulator system, and a CP13 HD camera installed outside the U.S. lab. That completed the main scheduled tasks for our spacewalkers, and they moved into get-ahead tasks, beginning with another age fixture removal by Hopkins, and APFR, or Articulating Portable Foot Restraint configuration for a future spacewalk by Victor Glover. Glover also removed and replaced an airlock magnet to help the thermal cover stay closed, and Hopkins took photos of the exterior of the station to document its current state. From the time the spacewalkers switched their suits to internal power at 6:56 a.m. Central Time this morning, it took them 5 hours and 20 minutes to complete the aforementioned tasks, concluding the spacewalk at 12:16 p.m. Central Time.
Okay, here's another one we recorded of it. Let's see what this is. Oh, that's the Earth. Look at that. Get the full view of it. Look at that. Isn't that nice? Wow. In that bottom right corner where it says 720, hit that little square and it'll take you back to the double view. We're going to look at this a while. That's nice, man. Viewing the Earth from out in space. Occasionally when you pull this software up, it'll tell you that it's nighttime and things like that. So we hit that 720 to go back to the double view. You see the path where it is over. It's over the ocean. It's like between South America and Africa, doesn't it? Oh, I like that view. Isn't that nice? A lot of clouds, but it sure is nice. This is free. Download it from your Play Store. It's ISS on Live. Sorry about the ads in the bottom. They just come with it. So that's why it's free. Next sunset in 1 hour and 13 minutes. It says it's a live video. Oh, I like that. That's about it for that video. We got another one coming up here. We'll see where it goes.
Equal to hundreds of images have been compressed into a single image. The sea surface reflects the radar signal away from the satellite and makes water appear dark. This contrasts with metal objects, in this case the ships in the bay, which appear as bright dots in the dark waters of the Tyrrhenian Sea. Boats crossing the bay in 2017 appear in blue, those from 2018 in green, and those from 2019 can be seen in red. Many large vessels depart from the port of Naples, one of the largest Italian seaports. From here, and the smaller port of Pozzuoli in the left, small leisure boats and ferries set sail to the nearby islands. Ischia, renowned for its thermal springs, and Procida are visible in the left, in front of Pozzuoli, while the beautiful island of Capri is visible further south. Numerous boats are anchored off the island of Capri. The island lies opposite the Sorrento Peninsula, to which it was joined in prehistoric times.
You can see the path there.
2 indentations can be seen in its cliff-lined coast, the Marina Grande on the north shore and the Marina Piccola on the south shore.
similar to Earth, how did their atmospheres evolve?
So Doug joined forces with Göran Moen, a professor at the University of Oslo, who started the Grand Challenge Initiative, CUSP. It's an international mission to launch 12 rockets into the Earth's northern cusp. And Doug, he's the mission leader for the first 2 rockets of the campaign.
We don't want to waste our rocket. It'll take us 3 years to make the rocket, only 15 minutes to use it, and I don't want to waste my shot here.
He's using a sounding rocket, which is different from the bigger rockets that carry satellites and humans into space. It's a small suborbital rocket that flies briefly into space, collects real-time data for around 15 minutes, then falls back to Earth. It's affordable, quick to build, and can launch towards a precise point.
The major advantage is that you can launch into a target on the sky.
But there's a limited launch window and only one chance to get the launch right.
We have these unguided rockets. They go where you point them, unless the wind is blowing, because the wind literally just blows them over. We don't launch when there's high wind.
So to measure the winds, they launch balloons with GPS trackers. They're released every 15 to 30 minutes, and then they're monitored to see how fast the winds are carrying them.
The ground winds were 12, 13 meters per second, gusting 17, which is way off.
You're filled with trepidation. Oh my gosh, this thing that I built, is it going to work after all this?
Is satisfactory. The 6.2 million pound Saturn V launch vehicle now on its own power at 38 seconds and counting. To repeat the ignition sequence.
Look, we're about to launch a rocket.
9 seconds with your liftoff at 0. T-minus 30 seconds and counting. We'll count down from starting at T-minus 1. T-minus 25. Stage is reporting ready for launch. T-minus 20. 19, 18, 17, 16, 15. 14, 13, 12, 11, 10, 9. Ignition sequence start. 5, 4. We have ignition. All engines are running. We have liftoff. We have liftoff at 7 a.m. Eastern Standard Time.
That's nice. Not many of us get to see a rocket launch.
Mark, 1 minute and looking good.
See the space station's over the South Pacific. This is all part of the app. You get to see NASA TV. They have all kinds of different things in it. Ooh, is that a stage? First stage is gone, looks like. another stage. We'll come back and record some more later. You need to get this, it's free. We'll see you next time.